Not quite okay. All right. Okay, let me go back and share my screen. All right. So this again is in the stream, and I'm just talking a little bit about what's going to be on the final. We're going to be reviewing for that today and Tuesday. So limits, and I'm going to talk about limits, remind you a little bit about limits, but go back. You should have notes on limits. Go back and look at how do I find the limit of right going to a certain value, right? How do I find a limit when it's going to positive or negative infinity? How do I know when a limit is actually going to positive or negative infinity? Okay. Definition of continuity. Definition of continuity. I'm going to talk a little bit about that too. Okay. And then this is something we've been doing already for a long time. Okay. Finding the derivatives of the sums, differences, power rule, product, quotient, trig, chain rule, exponential, log, inverse trig, and then, oh, did I say exponential log? And then of course, natural log, okay? So all of those that we've been doing, you know, for quite a while. So all of that good stuff is there. Do you know how to find the equation of the tangent line? Okay, that's definitely gonna be a big question. Log differentiation. Okay, can you do log differentiation? I did not put this, I should have this here. Also implicit differentiation. So I left that out. Let me go back and edit that. I'm gonna put that right here. Okay. Log differentiation, and then lastly, the motion problem. Okay, there will be a motion problem similar to the ones that you've been practicing. Okay, do you recognize when to use the position function, the velocity function, acceleration? Okay, all of those types of questions that you've had. All right, so that's pretty much, now obviously I can't, you know, I'm not going to be having a lot of each of these, okay, because like I said, there's a time constraint. So keep that in mind. Also, the final will be 2 parts, okay? One part will be multiple choice, and the other part will be some free response questions like we've done, where you'll take pictures of your work and send to me. All right. I know we got Liam here now, which is great. All right. I think we're just missing, Jaden. So hopefully Jaden will be able to show up. All right. Anybody got a question then about anything to do with finals and the final?
Will we get a review paper or anything, like any type of review? Or is that kind of on us?
I'm not really giving any type of, basically that list that I have right there is kind of like your review. You want to, I mean, I know it, you know, you want to go over those problems, but in the homework assignment that's due on, I think I made it Tuesday night, there's review problems from unit 2 and unit 3. Okay, so that's kind of like, those problems are your review problems, but I'm not giving kind of like a review guide, okay, of each of those, because those problems are in those review sections. So let me kind of actually show that too, so that you, because I have also edited that, meaning I've added more problems, which I think I had told you I was going to be doing. So, okay, so if you look right here, wait a second, I thought I changed this date. Did I? Oh, I did. Okay. Sorry, I'm seeing, I didn't change it there. Okay, let me change that so people, I hope are, I did change the date to Tuesday the 15th. I didn't change that up here though. Okay, sorry about that. All right. Okay, so within this assignment, oops. Okay, so within this assignment, these problems down here on page 286 and 161, these are review problems, okay? So these are pretty much review of all of those topics that I just listed, all right? So that's kind of right here is kind of like your study guide, okay? These review problems, okay? That list that I put in the stream, that's kind of something that you should kind of go through and just go, hey, do I know chain rule? And I hope everybody does. Okay, we've used it a lot. You know, do I know chain rule? Do I understand implicit differentiation? Do I understand log differentiation? right? And if there's one of those topics that you're not sure about, that's what you want to definitely talk to, if you have a study partner, or talk to me, okay, one of those. So with that, I'm going to go ahead and do I have, okay. I'm going to stop for a second. Okay, so with that, I want to first ask questions with any of those problems, questions with one of the, any of those motion problems.
Could you
Because
go
definitely,
over
yeah.
with the like one of the motion problems?
Yes. Which problem would you like to look at, Liam?
I don't have a specific one. I'm just feeling a little shaky on those ones. So
Okay. Why don't we look at number 4? Okay. So if you've done number 4, that's great. If you haven't done it, okay, follow along. I'm not going to do all of number 4, but well, we'll see. Let's look at it. Okay. So I'm actually going to use my stylus today. Okay, not the DocuCam. Okay, I will go back and forth with those. Oops, sorry. All right. Okay, so problem number 4, it looks like this. We are given the position function. So this is number 4 in the PDF that I posted. Okay, so we're given the position function. So again, really important to understand that okay, so it's really important to understand that this is going to give me the position. Okay, this is going to give me where, right? Maybe it's going to be at 3 feet, maybe it's at 10 meters. Okay, it's going to tell me its position in respect to time. Okay, so that's my position function. The first thing I'd want to do is go ahead and put this in my calculator. Okay, so I will go ahead and show my calculator, but go ahead right now. In fact, anytime I'm doing these problems, that's the first thing I am going to do is put that in my calculator. All right. So of course I'm using X instead of T. So I'm just going to put in X squared times e to the negative T, or e to the negative X. And make sure you use the negative symbol under the 3, not the minus, okay, or you'll get an error. All right. Okay, and again, be careful putting things in your calculator, all right? So that's my position function. If I wanted to right now, okay, I could find, right, what's its position at 0. In fact, I would even hope you probably don't even need to use a calculator to do that, because I know 0 squared is 0, 0 times anything is 0. So its position at time 0 is at 0. Okay, I can see that, all right? So let's go through some of the questions. So the first thing it asks you to do is to find the velocity at any time t, and then find it at 2 and 4. Okay, so let's find the velocity. First thing I'm noticing is this is a product, which means I have to use product rule. But I also am noticing that e to the negative t, this is a composite function, okay? It's not just t, it's negative t. So I'm going to have to use chain rule when I take the derivative of e to the negative t, okay? So I'm going to do this really carefully. In fact, I'm going to have somebody else do this really carefully. How about Tristan, would you take the derivative for us?
Yeah, it will be 2 times t times the derivative of e to the negative et, so it will be the same thing.
Wait, are you using product rule?
Oh no, I'm just saying it's gonna be e to the negative t.
Right, but if you took, I'm going to go back and just write product rule here for a minute, because I know you're doing it you were starting to do it in reverse, which is fine. But I know I always use, right, that it's, oops, hold on, oops, that it is f times g prime plus g times f prime. Okay, so I'm going to start, I always leave this one as saying t squared. So that's going to be t squared times the derivative of e to the negative t, which what would be that derivative, Tristan?
It'll stay the same.
Yes,
But with the
it will, but we're also going to be timesing by
-1.
-1. Okay, be careful. There's a few of you guys that are just doing this, and I've talked about this a few times. You're putting just like -1 here, you're not putting the times, and then you're thinking that this is all, you're thinking that it's this -1. It's not, it's times -1. Okay, so I suggest putting a grouping symbol, okay, so you don't make that mistake. All right, I am going to simplify that a little bit though in a minute. Okay, so good, plus. Now e to the negative t stays the same, times, and I know this is what Tristan was putting this one first, but I'm going to put it, I like to kind of stick with this. It's okay if you flip these around. Okay, that is okay. But I just know I'm trying to be consistent with how I've been presenting it. Times 2t. Okay, so that is my derivative. Now I'm noticing that I have one term plus another term. And I know I'm going to be putting this in my calculator, but I am going to just simplify it a little bit. So I'm going to factor out, it looks like we both have, there's a t that I could factor out and the e to the negative t. So I'm going to do that. So I'm going to put t times e to the negative t. Okay, and that's going to be, I'm going to have what, a negative t. That's what I'm going to have left here, a negative t. And I'm going to have over here a 2. Okay, so in my calculator, okay, in fact, I think I'm even going to go ahead and write that a little bit. I'm just going to write t e to the negative t times. I'm just going to switch those around. Okay, this is what I'm going to put in my calculator. Okay, so this is a little bit easier to input than this up here, okay, which is why I simplified it. So everybody go ahead and put that in their y2. And okay, all right. What do I have to do next? Now I have to find it at time 2, and I have to find it at 4. So I'm going to go ahead and stop sharing there for a second. And sorry, I'm going to be switching. I don't know, I might go just back to using paper. We'll see. Okay. Okay, here's my calculator. I have those two in my calculator. It's really important that you know how to do these things on your calculator because, as you guys know, the test is timed and you got to be able to do some things fast. So first of all, I have my velocity is in my y2. So I am going to, instead of graphing these right now, because I just want to find it at 2 and 4, I'm going to hit second quit so that I go to my home screen. And, you know, I could clear that if I want. I am going to choose the VARS button, okay, which is to the left of the clear. So I'm going to click on the VARS button, it's standing for variables. And it comes up and it says VARS, and I'm going to go to YVARS to the right. And it's on function. I'm going to hit enter. And I'm going to go down to Y sub 2. And I'm going to put a grouping symbol, and I'm going to put in 2. And I'm going to hit enter. Okay, and it's going to give me 0. All right. Now I know that I could have, you know, I could have easily put that right. Now that I think about it, that was really easy to see with that equation. Okay, but I'm also wanting you to practice this with the calculator as well. Now, what I'm going to do to save on time, if I want to copy something that's in my calculator, I hit second enter. So I'm going to do that. So I'm hitting second, and then I'm going to hit enter, and it just copied. Okay, what I had previously put there, and I'm just going to go back and now change that 2 to a 4, and I'm going to hit enter again. Okay, and I'm going to write that down. Okay, so it looks like it's at negative 0.147. Okay, so if they had asked me now to find what's the velocity at 10, like again, I could hit second enter. Okay, and I can go ahead and change that to 10 and I can hit enter. All right. So you do want to know how to use that VARS feature. If you don't, I know that like Misael in tutoring the other day was saying he wasn't really, practice it a couple times. Okay. You practice it a couple times, really do it really fast. Okay. Also that second enter is really important to be able to do too. Okay. All right. So we have the velocity function. Since I've already got my camera on, I think I'm going to switch. Okay. So what was it? I'm going to write it right here. It was t times e to the negative t times 2 minus t. Okay. All right. So the next question, it says, when is the particle, right? When is the particle at rest? Okay, so what does that mean? When is the particle at rest? How about Edgar? What does that mean?
When x equals 0, I think.
That's right, when x equals 0. Okay, so at this point, I could graph this. Okay, I could graph my velocity and I could find using the 0 features. Okay, I could do that. But I'm also noticing that because I've written this as a product, it's pretty easy to see when it would be equal to 0. So if I set this equal to 0, I have t times e to the negative t times 2 minus t. Because this is a product, I know, right, 0 product property says either this equals 0 or that equals 0. So t times, and I'm just going to rewrite this as, when does that equal 0? That's a question. Or, okay, so it's pretty easy to see when is it going to be 0? Well, this is at 2. And this one, first of all, e to the t in the denominator, this is never going to be 0, okay, because e to the 0 is 1. In fact, we know this is never going to be 0, so that's just at 0, okay? So you might be able to look at it and see that pretty quickly. If you don't, okay, you could graph it and use the 0 feature. And again, if you're not sure how to do that, talk to me later, okay? And I can show you how to do that, but you should know how to do that from pre-calculus, okay? But I know some of you didn't take it last year, so if you're a little rusty, just talk to me. Okay, so we found when it is at rest. All right, next question. When is the particle moving in the positive direction? So that's where I'm going to now look at. Okay, so here is this is going to be my time that I'm looking at, okay? And I'm just going to I'm going to put v of t either on the top or on the bottom, doesn't really matter. I think I'll just put it right here. Here's v of t, okay? We already know that at 0, okay, v of t is 0. And we also know at 2, it is 0. So now, again, I could look at that graph. And I haven't graphed this yet. I think I'm going to now, right now. Okay, so I'm going to go ahead and go back to my y equals, okay? And because I'm just looking at velocity, I'm going to go ahead and unhighlight my equal symbol on my position function. Okay, so I'm going to take that off. So that way it's only going to graph velocity, okay? And I'm also going to just go ahead and click on my window, because I'm really only interested in from, what are we looking at? Actually, it doesn't really say. I'm just going to look at this from, say, 0 to 6. And I'll make a scale of 1. And I'm not really sure what my y mins are. I'm just going to stick with the classic -10 and 10. And I'll keep a scale of 1. Okay. If I need to go back and adjust that later, I will. Okay. And I'm going to hit graph. Okay, so it looks like I probably would want to go back and change my y's, okay, because that's it's actually really hard to see what's going on. So I'm going to go back and I'm just going to change, instead of negative, I think I'm going to look -1 to 1. You could do -2 to 2 if you want, and I'm just going to change that scale to 0.5. Okay. Okay, that's nicer. I can see what's happening. Okay, so I can clearly see that between 0 and 2, how about Aiden, between 0 and 2, is the velocity positive or negative? Aiden, are you there?
Sorry, I had the mute button on my headset turned on.
okay.
That would be positive, right?
That's correct. Okay. Now, some of you might not even have to make, you know, you might not have to make this. Okay. But I'm doing it because it's kind of just helpful to have it. So it definitely looks like between 0 and 2, not looks like, it is between 0 and 2, it's positive, which means it's moving to the right from 0 to 2, moving in the positive direction. And then it looks like after that, it is moving to, it's negative. So it's then moving to the left, all right, or in the negative direction. So I'm just going to go ahead and put positive here and negative here. And to save on time, I'm not going to write it, but I put, you know, moving in the positive direction between 0 and 2. All right. Okay, let's move on. So it says, draw a diagram to represent the motion. And I don't know, this one always seems to kind of confuse people a little bit, but it really is helpful to just, we already can see what is happening, okay? At time 0, from 0 to 2, it's scooting to the right, okay? So think of something that's moving to the right, and then at 2, it stops and it turns around and goes to the left, okay? That's what's happening, but I do need to know the position. Okay, so that's important. I have to know the position. So I am on, this is E. Sorry, I haven't been labeling these, but this is E. So I'm going to do the same thing. I'm going to make kind of a number line, but it's not going to be time. Okay, that's what's important, is this is the position function. Okay, so I'm going to put f of t. Okay, so I now need to find what is the position function at 0. Well, we already did that one, right? The position function, but I'm still going to go ahead and put that, move this up. So over here, I have to find f at 0. So again, I'm going to go to my calculator. I know we already know it's 0, but I'm going to go back to my calculator. Oh, good. It looks like we have Jaden joining us. And I'm going to go back and highlight. I'm going to turn on my position function. Okay. And then I'm going to go back to second quit. So I go to my home screen. Jaden, we are halfway through problem number 4 on the motion problems. Okay. Okay, and I'm now going to go ahead and do my vars again. So I'm going to go to vars. I'm going to go to my y variable, hit enter. I'm choosing y1 because that's where my position function is in. And I want to find it at 0. And it's 0, like we already knew. Okay. But I also want to find it now at 2. Okay, I want to find it at 2 because I know that's where it stops. So again, I'm going to hit second enter so it copies what I just did. And I'm putting 2. And I'm going to hit enter. And that is 0.541. Okay, and I do want to go out 3 decimal places. Okay, so 0.541. So 0.541. All right, so that's going to help me. So my particle, and I think I'm going to use a little smiley face because it's Friday. It's kind of nice, it's Friday. So right here, this is 0. It's not 0 time. This is the position function, remember? So right here is my particle. Little smiley face, okay? And we know it's going to the right. It's going to the right for 2 seconds. And where is it stopping? It's stopping at 0.54 units. I didn't put meters or feet on these, okay? But if it was meters, I would say 0.541 meters. So that's gonna go, I'm just gonna go ahead and put 1 here. Okay, so it's basically going like this, and it's gonna stop right here at 0.541. So it's gonna stop here, it's gonna rest, right? This is gonna be at 2 seconds, and then it's turning around and going that way. That's it. Okay, that's my diagram. Not too bad. Hold on one sec. Whoops. Okay. All right, let's look at the next question. So the next question says, find the total distance traveled for the first 5 seconds or 5 minutes. I know there's not units here. Okay, so let's do that. So if I'm going to do that, I'm now going to have to find, well, where is the position function at 5, right? Where is it at 5? So I'm going to have to do that, f at 5. Okay, so again, thankfully, I still have my calculator set. All I have to do is hit second enter. Okay, and I'm going to put it at 5. And it looks like that is 0.168. Okay. And please stop me if someone, if you've gotten lost. Okay, so that tells me that it's going right. So I'm going to go ahead and put, so E, this is F, so I'm going to move this up a little bit, sorry. I'm going to put distance. Okay, so from 0 to 2. So from 0 to 2, it traveled 0.541, correct? Yes, everybody? Yes, okay. 0.541, okay. And then from 2 to 5, well, what did it do? It started here. It's going this direction. It stops at right here is 0.168. How am I going to find that? Who could tell us how am I going to find that distance? How about Sergio? How am I going to find that?
Wouldn't you subtract it?
Exactly. Yes. Thank you. We would subtract that, right? Okay. So that's what we're going to do. So this is going to be 0.541 minus 0.168. Which looks to be 0.373. And then what is the last thing I have to do is I have to add those two together. Okay, so I'm going to kind of leave that for you to do, right? I would want to add those together because this is the one distance, this is the other. All right. Okay. G, find the acceleration. Okay. So acceleration, how are we going to find acceleration? How about Misael? How are we going to find acceleration? Misael, are you there?
The derivative of velocity.
Exactly. Yes. So let's go ahead and write down, we have v of t. Okay. And this is one reason why I kind of simplified it a little bit because, I'm going to have to take the derivative of it. So what was it? It was t e to the negative t times 2 minus t. Okay. All right, so we have to take, now this is actually a little bit complicated, correct? Because I'm noticing that this and this is a product, okay? So this is F times G, okay? But I'm also noticing that this is a product, okay? So I'm having to do product within product, right? So I want to just kind of be careful as I do this. Okay, so I'm going to put A of t. Okay, so again, product rule is F times G prime plus G times F prime. All right, so this is going to stay the same. So I'm just going to write it. So it's going to be t times e to the negative t times, okay, the derivative of 2 minus t. Well, the derivative of a constant goes to 0. The derivative of negative t would be negative 1, right? Okay, so again, I'm going to put that in grouping symbols, times negative 1 plus, okay, now this one stays the same. So, and again, I'm just going to keep that in grouping symbols because it's 2 terms, times, now I'm taking the derivative of this, and again, I'm using product rule. So let's do it again. Okay, so this becomes my F, this becomes my G. So this one stays the same. So it's times, and because I'm using product rule, I'm going to use grouping symbols around it, okay? Because there's going to be 2 terms. We did the derivative of this, right? You might remember we did the derivative of this when we found velocity. So I'm going to do that pretty quickly. So t stays the same. So it's going to be t times e to the negative t times, again, a negative 1 plus basically just e to the negative t times the derivative of t is 1. So e to the negative t. So I'm getting at the end of that page. Times a 1, I'm just going to leave that off. Okay. All right. Let's simplify that a little bit carefully. Okay, so first of all, I've got this term plus this is all being multiplied. Okay, so this one right here becomes negative t e to the negative t. Okay, plus I'm going to keep that 2 minus t times this becomes negative t e to the negative t plus e to the negative t. Okay. So this
Wait,
could, oh, go ahead.
sorry, where do you get the -1 from?
I got the you're talking about right up here?
Yeah.
Well, because e to the negative t, this is a composite function. So I had to take the derivative of that inner function, which was
Oh,
negative
yeah,
1.
right.
Okay, yeah. But I'm glad you asked, okay? And of course, this is a pretty complicated problem. If I make a mistake somewhere that you think please pipe in, because, you know, I could, all right? Okay, so at this point, I think, even though I know I could simplify this, I think I'm just going to leave it like this, and I would put this in my calculator, okay? So I'm going to leave it like that, even though I do know that I could simplify it. I don't know. Maybe you know what? Maybe I will simplify it. Sorry, guys. Maybe I will simplify it. Okay. So I'm going to simplify it a little bit. Okay. By distributing over here. So I'm going to keep this one. All right. So I'm going to go 2 times here. That's going to be negative 2t e to the negative t. I'm going to times here. Okay, now I'm going to multiply here. So that's going to be a negative t times a negative t. That's going to become positive t squared e to the negative t. This is going to be a negative t times a positive e to the negative t. That's going to become negative t e to the negative t. All right, so I got 5 terms there. And let's look at each of those terms. Looks like I can definitely factor out an e to the negative t. Doesn't look like I can factor out a t because this one does not have a t. Okay, so I'm just going to factor out an e to the negative t. So e to the negative t. I'm going to have a negative t minus 2t plus 2 plus t squared minus t. Okay, hopefully everybody's following me. All right. It's actually gotten a little bit simpler, right? Now that I've kind of simplified this a little bit. Because a negative t minus a 2t minus a t, that's negative 4t. I got a t squared, I'm going to put that in front. So I got t squared minus 4t plus 2. Okay, there is my acceleration. All right. Lots of fun algebra. Yeah? I hope you guys are,
Yeah.
yeah, it's kind of fun. I don't know. I love it when algebra, all of a sudden something really complicated kind of is not as complicated. It's kind of satisfying. It's nice. But anyway. All right. I'm going to put this in my calculator. Okay. So this is going to go in my third y equals. And let me do that. Okay. So all right. And now I am going to find the acceleration at t = 4. Okay, so again, here I've got all 3 of these in my calculator. I have all of their equal symbols highlighted, okay? So again, I'm gonna go to second quit. I'm gonna go to my vars. I'm gonna go to yvars. I'm gonna choose y sub 3, okay, because it's that, and I'm gonna put in 2. I'm gonna hit enter, and hopefully you guys got the same thing, negative 0.271. Okay. Is that what other people got? Yes. Okay, good, thank you. Okay, because making sure too, it's always good to kind of double check and make sure that you put it in the calculator correctly. Okay, so now it says graph the position function, velocity, and acceleration. Okay, so I'm just gonna hit graph. You don't have to draw a picture of this, but look at it. Okay, it is definitely important to kind of look at this for a couple of minutes. Well, not a couple minutes, but look at it just so you kind of have an idea. Okay, so we know the red one was velocity. Okay, and the last one, right, that black one was my acceleration. Okay. All right, almost done with this very long problem. Okay. Last question, it says, when is this particle speeding up? When is it slowing down? Okay, so that means I'm gonna have to look at, we already have our velocity. In fact, I'm gonna go back to it. Oops, where was the velocity? Here it is. Okay, so here was my velocity. So what I have to now look at is acceleration. Okay, I have to look at acceleration. So when I look at acceleration, I can see that, and we're looking at this from 0 to, doesn't say actually, when is the particle? I'm going to assume from 0 to 5 actually, okay, just to have an idea of it. So I'm going to now put, I already have velocity here, right underneath it, I'm going to look at acceleration. So I'm going to have to find, I'm going to add 1 to this, okay? And I might be adding some other things. So the first thing I need to do is find, when is acceleration 0? Okay, so when is acceleration 0? So I'm going to go back to my graph, and I am going to unhighlight. Okay, so I'm just going to look at acceleration. And I'm going to look at, I'm going to just use, right, the zeros. So it looks like it's definitely crossing. So again, I'm going to go to second calc, and I'm going to go down to 0. And I'm going to get on the left side of that. And I'm going to get on. And it looks like it is at 1, right? It is at 1. And it looks like this is 2, 3, 4, 5. Okay, at 5, it looks like it's still negative. So from 0 to 1, acceleration is positive because it's above the x-axis. And then from 1 to 5, it is negative. So let me go ahead and put that in. Okay, so I already knew that velocity is positive here. It's positive between 0 and 2. Acceleration is from 0 to 1. It's positive. Right here it is 0. Okay, and then it's negative pretty much the rest of the time. Okay. So when is the particle speeding up? Okay, well, that's going to be when they have the same signs. So that's going to be right here between 0 and 1. And it's going to be after 2. Okay, so it's going to be speeding up. And it's going to be slowing down here. Okay, and of course, I would write that with interval notation. Okay, so I would just put, I would write out speeding up, and I would use open brackets 0, 1 and 2 to 5. And then I would put slowing down between 1 and 2. Okay.
Wait, can you zoom out so I can take a screenshot of the entire problem?
The entire problem?
No, I'm just
Um,
saying the beginning.
Yeah, from the very beginning. Yeah, I could definitely, do I have it from the
No,
very,
not the entire problem, just the beginning.
just the very beginning? Okay, where's my very beginning page? You know what, part of it, I did the very beginning, I did that on, the whiteboard. So I don't have it actually on the paper.
Yeah, I just meant whenever you started on the paper.
Oh, okay, okay, I'll leave that right there. And also, guys, there is a plethora, meaning there's many, many, many videos out there of these problems, okay? So, you know, if you're at home and you're still confused with one of these problems, just put in, you know, just put in velocity plus calculus videos. There's going to be so many. In fact, there might even be some on my YouTube page. I'm not sure. Okay, I will actually go and look and see. But, you know, there's definitely problems out there. And also I have recorded this. So I can put this, in fact, I'll put this on my YouTube channel. I'm not very popular. I don't have a lot of people that follow it, but I'll put it on there so that you can go back and relook at it if you want.